Hello, this is Categorical. Welcome to today's session. In today's brief video, we're taking a look at the concept logistic regression. We'll demonstrate it using JASP, and as we do, we'll come to appreciate its application when it comes to research. Are you new to the channel? We encourage you to subscribe to the channel so you can always get notified whenever a new video is released. Now, if you watch this video right to the very end, you stand a chance of knowing some basic matrices that are calculated for when one is undertaking the logistic regression. That is not all. You also come to appreciate how you can apply this knowledge to a real-time data in order to make deductions or conclusions. Now, having established this, let's see what logistic regression means. Now, logistic regression is calculated for or is undertaken when one seeks to find how an independent or independent variables predicts a dependent variable. Here, the dependent variable or the outcome variable of interest should be binary or categorical in nature. Now, if you watch our video on linear regression, you come to see the difference between the linear regression model and the logistic regression model. So while in the linear regression model, we have the dependent variable being continuous in nature, in the logistic regression model, we have the dependent variable or the outcome variable being binary or categorical in nature. The difference between the linear regression and the logistic regression has to do with the nature of the dependent variable or the outcome variable of interest. Now, the gender, which is male or female, an outcome of a test which is positive or negative in that regard. Now, another assumption is the fact that there should be the independent variable or the predictor variable must be continuous or categorical. Now, the linear relationship must exist between the continuous independent variable and then the dependent variable which we are trying to explore. Now, there are some basic matrices that are calculated when one is undertaking a logistic regression. Some of them include the IAC and then the BIC. Now, the IAC is the archaic information criteria and the BIC is the Bayesian information criteria. Now, these two information criteria basically helps one to measure the fit of the model, and then the best fits always have the lowest value of IAC and then the BIC. Another matrix which is calculated for is the pseudo R squared. Now, you remember that in the linear regression model, the R squared is calculated. Now, in the logistic regression, the pseudo R squared here is not exactly a replica of what we have in the linear regression model. However, it is very useful when comparing different models for the same data sets, where the model with the highest or the largest R squared, pseudo R squared statistic is considered to be the best. Now, another matrix that is calculated for is the wild test. Now, the wild test is used to ascertain how significant the independent variables are statistically. And so it has values such as the wild statistic, and it also has the probability value of that. And based on the p-value, we can be able to tell whether the statistic is actually significant or not based on the alpha value or the significant level that we set. Now, another parameter or matrix that is calculated for is or presented is the confusion matrix or the contingency table. Now, this basically gives a tabulated form showing the actual or the predicted outcomes. It is also used to assess the accuracy of the model in what we call the sensitivity, where we are able to tell what true positives are, and specificity, where we are able to tell what true negatives are. Now, the null hypothesis that is tested for when undertaking a logistic regression is the fact that there is no significant prediction of the outcome variable by the predictor variable. Basically, this is a summary of the logistic regression and what goes into it. Now, we want to go to the JASP platform and see how we can have a practical hands-on demonstration of this concept herein defined. Now, let's go to the JASP platform. Beautiful. So here we are on the JASP platform. So we'll click here as usual, and then we'll click open. We'll go to our data library and try to look for regression and try to see which of the regression data set will help us to explore what we are talking about here. So we're looking at logistic regression. So obviously this data set on Titanic would help us in that regard. So we load our data and we want to see what the values or the data set looks like. So we have name, we have key class, age, sex, and survivor, and the data are presented. Now let's see a brief description of that data. This is Titanic, Logistic Regression. The description: this data set Titanic provides age, cabin class, and survivor status of 1,313 passengers on the Titanic. And the variables as we have explored are these. Now this example just presents the use of logistic regression. Specifically, we are interested in the extent to which passengers' age, notice, and cabin class predict whether or not the passenger survives. So here our focus is to see whether the age of the person influences the age of the person, and also the cabin class influences his or her survivor on the Titanic. Now, for more information, you can copy this link here and put into your browser, and you can have a video that will help you to see how this is done. Great. So we established that our outcome variable of interest should be categorical. And so when we see our data or our just platform here, this is logistic regression, obviously, and survival rate is either you survive or you do not survive. And so it's categorical in nature or binary. And then the age is continuous, and this P class or the cabinet class is also not continuous but categorical. And so we can use this model in doing our analysis. We will not use a linear regression model because survivor, which is the outcome variable, is not a continuous variable. Now, when we click on the statistics here, we have the confusion matrix, the sensitivity, and the specificity. We can equally check other statistics that will help us to see the performance matrices, but our interest here is just the sensitivity and specificity. We also have odds ratio, which will help us to see the coefficients for the regression models. You can equally check all this and see how they manipulate in telling us the outcome here. But for the sake of this video, we'll limit ourselves to the various checked parameters and then more statistics which we would employ. So now upon the analysis, we said that our p-value is of interest to us, and we said the AIC and the BIC help us to see how our model is fit. And here we can see that it is smaller than the NAR. So obviously it is better than it. And then when we look at the ratio here, the odd ratio here, comparing the intercepts, or where we have age as 0 and the class as 0 or 1, or the reference as 1, we see that the odds are very high, or the odds of survival is very high. So let's see the interpretation for this analysis. So first of all, we're looking at this, which is significant. We look at this and see our model is better in prediction. And then we also look at the coefficients. The coefficients, we look at the intercepts where all these variables are 0. Now, let's look at the interpretation. When we interpret the odd ratio for surviving the data, we have to keep in mind that the value 0 for the continuous variables and the first factor level of the categorical variables are serving as reference class for the model. So what that means is that age 0, which is our infants, are automatically used here as our reference, while the class, which is here giving us class, first class, second, and third class. The first class is also coded as 0, that is the reference class. So the age 0 infants and reference class compared to all this, what is happening? Now it's telling us that in our case we have age as 0 continuous and passenger class as the categorical. That's our reference class are newborns or passengers with age 0 who were traveling in first class. Their odds of survival, which are infants traveling at first class, their odds of survival is 7.6. That is what we see over here. It's 1, which means that their probability to survive was 7.6 times higher than their probability of drowning or getting dead. So basically, that is the interpretation we can give to this. Holding all this against zero, the reference, we can see that the odds of surviving when you are infants and at the first class is 7.6. However, when you are older than 0 years, your odds of survival is about 4% reduced risk of surviving. And then when it comes to this one, you subtract this from 1, which is what? 68. So you have 68 reduced odds. When it comes to this case, so we also have about 89 reduced odds. 89% reduced odds of survival. Basically, that is how we can be able to interpret these odd ratios. Right, so this is basically how logistic regression works. You have a dependent variable being categorical, but this is catalytics. Until we meet again, it's a wrap.